Okay, today we're going to take a look at ETCAI's power supply challenge, and we're going to troubleshoot a full wave rectifier with we'll do the troubleshoot today with the oscilloscope. So take full wave troubleshooting with oscilloscope right here. We're going to have very similar readings to what you see in the example down here, except this is a bridge rectifier, which is a full wave rectifier, but this is the bridge version. We're going to deal with a center tap transformer with the full wave here. So troubleshooting with oscilloscope, here we go. We have a 7-volt voltage regulator here. So on this particular one, I should see a voltage input just about 2 volts or more over 7 coming into my voltage regulator. And we're going to 120 volts in and 20 volts on our center tap. So what does that look like in our troubleshooting here? As we did with the half-wave rectifier, I like to start on the primary coil using the 50 volt max. I should see my AC input of my full 120 volt signal coming out there. And let's take a look at the secondary. The secondary has nothing on it, so my problem lies in the transformer. It is either the transformer's primary or secondary coil. Remember, you do take a slight point hit by pulling the ohm meter out. The easiest way to determine whether it's the primary or the secondary is by double clicking on the transformer, putting the ohm meter on there, and notice that this secondary coil is bad because it has an infinite resistance there. So that's our transformer secondary. Turn this off. Transformer secondary is our issue. Grade our selection. Move on. You're going to find that the problems are very similar to what you ran into on the half wave, except our readings are just a little bit different because we have a center tap and 2 diodes here. So either diode could be our problem. So let's take a look here again at our next power supply and see what we get. So we got a good AC signal coming in. We have a bad AC signal coming out. We'll double click. I should double click on the primary side. Let's go ahead and ohm meter on. Now notice secondary side is great. So obviously the primary was our issue on that one. So this is a primary coil problem. We grade our selection, move to our next power supply. So on this guy, we have nothing on our AC signal coming in there. Let's see, is it the fuse? Nope, it looks like it's the switch. So the switch is the issue. We'll go ahead and select that, grade the selection, next power supply. Let's see here, primary side looks good, secondary side looks good. Now what does it look like at our diodes? So when we take a look here at our diodes, we do have a filtered waveform signal up there. Now I'm on DC sense, I'm going to just put this, and it looks like both diodes, you're going to see both waveforms here, both diodes are being filtered. So knowing that, let's take a look and see what's going on here at the voltage regulator. Remember, this whole line is going to see the same signal all the way into the input of the voltage regulator. My guess is the problem is going to be our voltage regulator. Let's see what the output looks like. And sure enough, that voltage regulator did nothing. The signal stays in a filtered state. So voltage regulator is our issue. So we're going to regulator problem, grade a selection, move on to our next one. Okay, let's see primary input. And I got nothing on primary input. Is it the fuse? Looks like it was the fuse. So fuse is the problem. Grade the selection. Next power problem. So we're looking here. Got a good AC input coming in primary. I got a good AC output coming from the secondary. So what does our diode look like here? Okay, and diode looks like a filtered waveform. But notice, and I don't know if you guys noticed that the last time, but look at the long cascade here. It's one of my diodes that's the issue. Okay, I do have a filtered waveform, but there's a significant voltage drop. So how do you know which diode it is? And that is a challenge here where you got to really look at the frequency of the waveform coming in to see which alteration is affected by the diode, and which diode itself is basically our flaw signal here. So I am going to go with diode 2 as my problem, and I was right there. So let's go ahead and next one. Again, primary inputs. I have a AC signal, looks like a good AC signal coming in, a good AC output signal, and let's take a look at our diode signal. Looks like we do have a filtered waveform here, and that filter does looks to be the right voltage distance here. We're going to take a look here at our voltage regulator output. Looks like our voltage regulator is giving us, oh, I gotta go to a DC sense. What am I getting on my voltage regulator output? So it looks like we're gonna go with our regulator. Now my gut's to go with the voltage regulator, but before I do that, there is something I do want to check, and this is the catch with our full wave rectifications. Let's go back and back out of my DC sense, back to my AC sense, and I do see a straight line output here, and back to the DC sense. You see it went up there. Let's go to 5, and so from our midline, 1 square from midline is 5, and it looks like we're 7 volts there, and that is what our specifications are on our voltage regulator. So it might be that we actually have a diode issue here. I'm going to back out. We're going to move our probe back over here to the diodes, and you can't check the center tap because center tap is ground. So you're on this side of your secondary and on this side of the secondary relative to ground. Well, let's come in here and look at our diode setting at let's go to an AC sense on the diode setting, and if we go to 2 volts to the division, we got 1, 2, 3, 4. I do think we got a diode issue here. I'm going to second guess myself and graded the diode, and I was right. Now I'll be honest with you, there's a little bit of a gut guess to that, but what we're looking at, notice one diode is in failure, and it is the voltage variation here now dealing in millivolts. This is 0.2 volts to the division, the millivolt fluctuation. If both diodes were working, I would have half of the peak to peak voltage drop that I'm seeing here. So I'm glad I caught myself there. We did see a 7. What I noticed was a 7 volt output, and that got me looking back at our diodes as our possible problem. So occasionally you're going to run into something like that. Do the best you can as you plug through these guys. Approach it very systematically, and you should find yourself successful. Good luck with this, guys. I failed to mention the last time, my gut was on the diode, and I forgot that you can actually check the diode. You can check the continuity of the diode. So I do want to take time to show you this. This is the next problem, problem number 8, and I'll work through it. We'll see what's wrong with problem 8, but I want to show you on this problem just how you can pull the diode out, check it if you need to check it. As I failed to mention, that is a way of figuring out for real which one is good or bad. Just like you can check the continuity of your primary and secondary coils on your transformer, and you can also check resistance of your resistor. You can check the continuity of your diode. So I'm going to show you how to do that. We're going to figure out what's wrong with the circuit here. Here we do see a rectified waveform. It looks like a decent rectified waveform that has been filtered, but let's take a look at our output over here on looks like so the real problem on this guy is our voltage regulator. We're not seeing let's get back here to 0, get that AC sense, DC sense with our regulator. Voltage is, yeah, so it looks like looks like our 5 volts rippled there. And go back to a 5-volt division, 1 volt to the division, fluctuation. DC sense puts us how many above? We are on a output of 5 volts. Definitely not outputting 5 volts. I'm not actually dropping it. So actually I'm thinking my resistor is my issue here. I'm thinking the resistors are issue because from midline we're 5, 10. Yeah, my resistor is actually my problem here on this guy. But so we'll take advantage right now of the ohm meter to show you. I'm guessing resistor, and so I'm going to go say turn that on. Now, resistor value actually isn't too far off. It's supposed to be 4700 and it's 49. It is higher than I wanted it to be. So maybe my voltage regulator. If I'm going to go with the diode, pull that out, I can check my diode, and turn this on. You can check your diode, and you see that diode's good. Now each time I pull an ohm meter out, I do take a hit on points. Turn that on, so both my diodes were good in that situation. We'll go with the voltage regulator and see how that does for us. Took a lucky guess there. Wasn't quite sure if I was seeing the 7 volts they were calling for the voltage regulator output, and I wanted to double check the resistor. So here again, I had a hunch voltage regulator was our issue, but I wanted to double check my resistor, and then I also just pulled these diodes out. I knew they were good, but I pulled the diodes out just to show you that you can check the diodes and their continuity as well. Each time you pull an ohm meter out, you do take a hit in your points, so do keep that in mind. Only use the ohm meter when you absolutely need to be certain. So good luck.